All right, we're live. What's up, party people? Doing another stream. It's like exercise. Like, just got to keep doing it. Sometimes you don't feel like doing it. Sometimes I don't feel like doing it. But once you start doing it, you feel great. So that's where we're at right now. Today, what are we doing? Well, first, let's tweet out a link. Make sure the stream is live. And then we can talk about what we're doing. Okie dokie. So what are we doing? Let's pull up my little to-do list. So basically, I want to try and spend 1 hour looking at LA pollution and demographic data. And this is for an upcoming margin story. And I've assembled some of the parts. I have census tracts, but let's talk through what I need to do in this hour. And the first thing I need is census tract shapefiles. Then I need demographics by census tract from the census. I don't need to say that. I don't need to say it's from the census, do I? What else do we have? Census tract, shapefiles, demographics. Oh, and then I need pollution by census tract, which I have. And then I need to make dot density demographics. And then I might make dot density from the pollution. Or a choropleth. So we need some way to visualize the pollution. Clearly, I have no idea how I want to do that. Choropleth bubble map dot density, we don't know. So this is the plan for today. Looking at Los Angeles, getting our data, making some maps. Love it. I'm going to start the clock. I got an hour on the clock. I think it's totally doable. I think it's totally doable. So let's look at our data and make this comically large timer a little bit smaller. So we have this data from, I think it's the EPA or Mason Grimshaw over at Earthrise. Hooked me up with this data set. So let's see what CS 4.0 EPA pollution data, something like that. Yes, the Cal Enviro Screen, CES 4.0. So I have this data set, and it's pretty interesting. So what it has is we have every census tract, right? And then we have the longitude and latitude of the centroid. We have the CES score, which I guess is an index that the California Enviro Screen makes. We also have a bunch of cool pollution data sets, right? So we have ozone, we have the ozone percentile of that census tract, we have PM 2.5, we have lead, pesticides, we have traffic, I'm not entirely sure what that means, cleanup sites, groundwater threats, and I have somewhere in here a data dictionary. Okay, yeah, so this explains what these things are. So like, PM 2.5 is the annual PM 2.5 concentrations. What is cleanup sites? I mean, not the most helpful. It's cleanup sites. That makes sense. Pollution burden. We have the low birth weight percentile. Oh, and then we have some basic ACS data, which I don't know, is it in here or it might be in another file? Yeah, see, they have more ACS data in this demographic profile table, which is also by census tract. Pretty cool and interesting. But I don't think that this is the demographic data that I am going to use. And the reason being that it's not HD enough for me. It's 320p and I want some 1080p data. So I'm going to download census tract data from the census for demographics. And actually, I think I already did that. Let me see if I can find it. So what is this? Open with numbers. Okay, yeah, so this is census tract data for California. Yes, and only California. And it's census data like the total white population, African American, American Indian, all of these different races. And this is what we are going to use to power the dot density map. So one of the first things that we need to do is bind in this ACS DT census data, census tract data, into QGIS and into our shapefiles. And so the shapefiles is the second thing that we need. And I got that from Tiger, I think. Let me see if I can recreate it. I already have it loaded in QGIS, but it's basically census tract boundary shapefiles. Yeah, I probably got it from Tiger. And I selected like just, let's see, congressional districts. Right, so I want 2021 census tracts, and then I selected California, and then I downloaded them. So now I have my census tract shapefiles. I have my demographic by census tract, and I have my pollution by census tract. So these are all done, which is great, very exciting. Okay, so let's make a map. So I have a QGIS project going, and maybe this is a little too far, so I'll step through it piece by piece. So first, this is just the LA County census tract, so we don't care about that. Let me just load in my census tract data that I just downloaded. We can get a sense of it. So let's just throw this guy in. Right, so these are all our California census tracts. They all have one color because we're not binding any data to them. And if you look at what a census tract looks like, it might be kind of hard to see, but it has a state code, county code, a tract code, a GeoID, which is really important because that's how we're going to bind our data. And that's pretty much, I mean, the A land and A water, really cool stuff. So what we need to do is do a join for our boundary files and both our pollution and our demographic data. So let's add both of those things. I'm gonna add layer, add delimited text layer. So this lets you load a CSV, which is what I have. Go on downloads, donde está downloads. So this is my tract CSV, right? It has all of our demographic data in it. A lot of it is null. Doesn't seem right. Maybe it's not, is it detecting the field types? I guess it is. Number of header lines to discard 1, okay. Okay, so basically this is our census data, and let's add it in. And then we need our Cal Enviro data, which I think is also in downloads. I might need to search it. Cal Enviro screen. Got it. So that's that's this guy. CES final results. Right, and so this also, see, I'm discarding my header field, which I should not do. We have census tracts and now our pollution data. So we have all of our pieces, and let's rename these things. So this is census tract, we'll call it CA census, I can spell. CA census tracts, this is our demographic census data. And this is our pollution data. And this is from before. I'm tempted to delete it, but I won't. Maybe I will. I'm going to delete it. Fresh start. So let's bind all these things together. And to do that, we might need to pad the GeoID so that it binds properly. And I'll show you what I mean in a second. So if we open the attribute table, so the GeoID, it's hard to see right here. Let's see. I do this. It's a big long ID. This is the FIPS code, and this is the census tract code. And actually, you can actually see that there, right? The tract code is 0000100. The state code is 06. The county code is 067. And the census tract code is here. So FIPS codes are strings. They are not numbers. They are IDs. They are not numbers. So they have a 0 in front of them, and that is for the first 10 states in the United States alphabetically, right? Alabama, Alaska, etc. So you cannot really turn this into a number or skip the preceding 0, or things will go out of whack. And this happens all the time, and it definitely happened in our pollution data. So let's look in our pollution data real quick. And what we're looking for is anything with a GeoID that starts with a 0, and none of them do. So here's an example from the first thing in geodata, right? Looks almost exactly the same, but it doesn't have a 0 in front of it. So we need to add that back. And we are going to do that with a calculated field in the pollution data, which I need to remember to make into a string. So we have all of our fields, and we're going to make a calculated field in QGIS. So the way that it's going to work is we're going to create a new field, and it's going to be called padded GeoID. Its output type is not a number, as we just discussed. It is text, and it is a string. And it is going to be made up of our, well, how do you pad? You want to pad left pad. Okay, so we're going to lpad the GeoID. Oh no, where's the sense that we're going to pad the tract with zeros, and I need to look up how lpad works again. So string width is, oh god, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11, fill is 0, right? And it's hard to see, but down there, it now has a 0 in front of it, which is exactly what we want. So we have a padded GeoID for our pollution. And now let's just double check our census data GeoID and make sure that it also makes sense and has zeros. Oh boy. All right, so it has geography, which is like a long, crazy GeoID that we might need to split. See, it says US and then 06. Okay, so we need to make a different kind where we split on US and use the second. So let's make a calculated field for our census data. New field, it's going to be calc GeoID, I guess. Importantly, as previously discussed, it is a string. So this is what it looks like, 14,000 US. So what I want to do is split on US. And let's figure out how to split things. Split. Oh no. All right, let's look at what we can do with strings. Strings. I don't want a regex at all. Substring? That's if I know how many. I guess I do know how many. Clipboard. Looks like this. Whoops. Right, so I guess I want to cut out the first 1, 2, 3, 4, 5, 6, 7, 8, 9 characters off it. I guess that's fine. So I want to do 9 to, I don't know, what is it, 14? We'll see what it looks like. With the, I guess I can do with this to start. Okay, so that is not enough. 10 to 20? That seems right. Yeah, 20 is as many as it gets. Okay, so So this works with our example string, and now we just need to feed in, what's the field? Whoa, geography. Great. So now we have our new calculated GeoID on here, and we can bind them both into our census tracts, which right now are pink, and very shortly will be not pink. Can't wait. So let's do joins. Vector join. So we're going to first pull in our demographic census data. We're going to do it on the GeoID. And that is the same. Oh, let me double check that. I think it's the same as the GeoID in our shapefile. And I want to join like all the fields, basically. They have terrible names. I'm not going to join. Oh, I guess I'll do this right. All right, so let's see. So we want white alone estimate, 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 estimate. Great. So we're going to bind on GeoID and hope it works. So this is our demographic data, and now let's bind in our pollution data. So pollution data, join field is our padded GeoID. Once again, I hope it's GeoID. Join fields. So in this one, we will join, oh, there's so many fun ones. And by fun, I mean interesting. This is really terrifying data when you think about it. I guess, should I pull in? I won't pull in percentile. I'll just pull in the raw values. Lead, pesticides, toxic release, traffic, cleanup sites, groundwater threats, hazardous waste, solid waste, pollution burden, asthma, education, poverty, unemployment. Great. So I'm binding in a bunch of pollution data. And if I did everything correctly, which I probably didn't, we should see those values when we try and make our fill color. So we will do a graduated on, oh yeah, look at that. So we have both pollution and demographic data. So let's look at PM 2.5. Move this. Got to classify to get our colors. All right. So this looks good, though it is a little weird, and this happened to me last time. It is a little weird that we have these holes. I wonder what these holes are all about. And this is why I have the LA County tracks underneath. So theoretically, you could zoom in and figure out what are the ones that aren't binding. So like this one, what is it? 06037551800. That's its GeoID. Let's look that up in the pollution data and just see if it's there. That is this one. So we want to find this census tract somewhere in there. Not found. Okay. So at the very least, it's not that we're binding incorrectly. It's that our data does not have anything for that place. I think there's a way to do null values in here. Like if it's none, then it gets something. I forget how to do that. All right, but anyway, so we have our demographic data loaded, right? Or our pollution data, I'm sorry, and we need to, let's check our demographic data. So let's do white alone and classify. And so this is where white people live. It looks like everything's bound. Are we missing things in our demographic data? I guess these are people. Okay, interesting. What about another race? Let's do Native American. Classify. Interesting. All right, so we are showing our demographic data as a choropleth, but that is not what we came here to do. I really want to try, and I've never done it before. It's interesting to try new things live. But what I want to try to do is use, I'm pretty sure QGIS has like a dot density mode. One of these modes. Could have done any amount of research before I started trying to do this, but all right, rule-based, no. No symbol, that's nothing. Single symbol. Oh, here we go. There used to be, I don't know what, oh, geometry centroid fill? One of these is like point pattern fill. Okay, this is sort of what we want. Point pattern fill. That is sort of what we want. I might, in a second, I'll look up how to actually do it, but it's always fun to poke around a program. So this fills. I want to, okay, so this is close to what I want, right? Like I can say the distance. I can make them like closer, right? Or further. But I want to control the number, like the way that dot density works. Actually, let's look at what I'm trying to do. Let's like just explain what's happening real quick. So dot density map. I think the one I really like is Unobservable by Aaron Williams, who is incredible. So this explains the process pretty well. And this is a dot density map of DC. And basically every race gets assigned a different color. And you can this is a fun one because you can turn them on and off, right? So if we turn just white on, so white is red. So this is where white people live in Washington, D.C. And then if you turn black on, then you can see this is blue, and that's where black people live. And you can sort of see the segregation of DC, which I think is really interesting, right? And the way that this is done is that you draw within a boundary a point for every 10 or 100 or wherever your ratio is. You draw a point and color it by the race. And so I'm going to try and find a resource that lets me do it in QGIS. Random points. Processing random points. Okay, this is going to be interesting. So let's put this back to where it was and just do a generic simple fill. Okay, so these are census tracts. And they say there's processing toolbox, random points in extent inside polygons. Okay, let's see what this does. Okay, so we can do California census tracts. Our sampling strategy is points density. Okay, so do I have to do this by race? Okay, so let's do. Okay, this is interesting. Okay, so I'm going to make a new layer that makes random points, and the density is powered by the white population. Skipping a lot of features. Okay, so this is, we can rename this white dot density. And let's do it again for every race. Points count, points density. Oh, what? Oh, I don't have the right thing selected. Random points inside count polygons. We want to do density powered by Black or African American alone. All right, so this is a great start because we can try and recreate what we saw before. So this is black dot density. So the way that Aaron Williams did it is that he had red for white, and so let's make a red marker. And they are much too big. So let's make it like 0.5, maybe a little bit more. Oh, and I hate the outline that they have. We do not want that. Solid line, no outline. Thank you. Okay. So let's zoom in a little bit. Interesting. Very interesting. There's not enough dots, in my opinion. Let's change the style of this. Just make it gray. This, I'll make a, what size did I make it? 0.9? Do a little 0.9 blue dot. All right, so a little bit of a black box QGIS. Oh my God. All right, so I might do this again because it just, and also this doesn't make any sense to me. I guess this census tract is enormous. Like it's, what is that? Who are you? That is census tract 187. San Diego. Okay, so that's San Diego. I guess that makes sense that a bunch of people live there. Are there any other? I guess I'm way off LA. Okay, that's part of my problem. And also these census tracts are kind of sometimes really big. All right, so part of the problem is I'm not seeing enough dots. So I'm gonna try and generate my dots one more time with my toolbox. Right, random points inside polygons. I'm gonna do points count instead of density. And I'm gonna do it with white alone again. So that's just, this is point counts. And we'll call this white count dots. Okay, this is taking much longer, which actually makes me feel a little bit better. I think because I didn't do any math on it, right? So I think it literally is drawing a dot for every single white person in every single census tract. And we might want to reduce that a little bit. So it's drawing a dot for maybe every 10 or 100 people in any census tract, but at least it's working in some way. It would be, it's not, I wouldn't say this is the like easiest possible way to go about accomplishing this task, but what are we going to do? Surf Twitter a little bit. All right. See, this is the fun part of data analysis. You get to let things bake. Like I used to like working in like 3D software, which was nice because you would like do a bunch of work and then you'd like let it render and you could sort of hang out and do other stuff. And this feels a little bit like that, where it's like it's still 25% of the way through. Should I put some music on or something? Make our lives a little nicer. I need a camera that like goes over the DJ table. I don't know. So going to do our dot density map. Then we're going to do it with pollution. If it takes this long, it's got to be because I'm trying to render too many. It's got to be. It's so slow. It's probably going to break. I just realized it when it's done. It's probably going to break QGIS trying to render it also. So I should try and remember to save my project. I'm going to drop a little update of the progress so far. There we go. So time's a ticking, and we're still only 50. See, now I'm in too deep to cancel it though, because it's halfway done. You might as well wait for the other half, right? And we can see what it looks like. And then next time we run this, or probably the next few times we run this, we can do it on like 10%, or divided by 100, or divided by 0.1, or just get a reduction in the scale. Scale is our problem right now. Might make more coffee. You can see what's going on. Steadily working. It's funny how delayed the stream is. I was just checking it. It's got to be like 30, 45 seconds. I got to fix that. It was annoying last time because Alex was like talking in the chat, and it made it really delayed. It made it hard to communicate. What else? What else we got going on? Anything fun? Oh, I can show while we're waiting for this to load. Yesterday, I was looking at the same data set, but in Observable to make some graphs out of it. So we can just see what that looks like. So basically, this is that same California Enviro data set, right? So it's a bunch of California census tracts. But this time, we put them on a scatter plot. So you can do the X, you can see some patterns pretty clearly, right? So if you do PM 2.5 on the X-axis and poverty on the Y-axis, right? It's pretty, as you increase in air pollution, you also increase in poverty. How do I do the linear regression line and plot? Linear regression, here it is. Give me a little linear regression guy. I might need to do it last. So it's drawn on top. Right. So that's our regression on poverty versus air pollution. We can also do poverty versus lead, right? The circle size is the total population, and I think I have that through. Yeah, I was trying to emphasize it a little bit, so we can turn this down. One, maybe 2. So the larger census tracts are shown as larger circles. But anyway, oh, and then I was highlighting in red the Wilmington zip code, which is I have a meeting in 10 minutes. Wow. All right. Maybe I'll hop back on and I'm actually working on this exact same thing. But let's see what else is interesting. Lead and solid waste, straight line. What about poverty is on the Y-axis and pesticides. Interesting. Not pesticide, asthma. Right? So this is asthma versus poverty. Straight up. I mean, it's pretty depressing data when you think about it. But I guess it's good that we have the data to understand how fucked up it is. Like, that seems good. A different way of sizing it. Yeah, so these red circles are Wilmington, which is where the subjects of our story are. So I was trying to see like how, like where in the pack they landed. Like if we do education versus lead, right? Again, it's like, I'm no fucking data scientist or whatever, but that looks correlated to me. And Wilmington sort of falls in, you know, the 90th percentile, like pretty far up there in terms of who's affected by lead. So is QGIS done processing? Yes, it is. Let's look at what it looked like and hope. Oh my God. All right. So let's fix this marker, turn our stroke off, 0.2. For our size, is that allowed? We change its color, make it red. Oh my God, there's so many. 0.2, please. Okay, so this is what I asked for. Unfortunately, I'm a fucking moron. But this is kind of what we want. What I asked for is I asked QGIS to draw a red dot for every single white person in California. And maybe I shouldn't have done that. But I did. And it took like 10 minutes to run. And it's taking like another, whatever, 2 or 3 minutes to render, which is like a bad sign. But it is what I wanted, unfortunately. So it's cool that works. So now we know how to make dot density. We use the let's do a little tweet where we explain how we do it. Random points inside polygons, and then we do this, make this smaller, and then we do census tracts field by this. So this information all together. Oh no. This information all together includes how to make a dot density. So let's see here. Sorry, I'm tweeting real quick. Where did my screenshot go? Oh, there we go. All right. Okay. Our hello world drawing a red dot for every. Yeah, and I might have asked for too many circles. Gotta fix my tense real time. Do you guys like my real time tweeting? Is that everybody's favorite part of the stream? Maybe. I tried to send a tweet on my laptop a minute ago and it didn't work. Okay, so let's look at our map. We made too many random points. I'm gonna hide them. That was really cool, but it wasn't what we wanted. So let's do random points inside polygons again. Let's use our white person field again. But let's edit it and make it much less. So we'll do times 0.01. So that's a point for every 10 people. right? Either way, it's less. So we'll do 0.001 and then see how long that takes to generate. And we're doing point count set by white. All right, and no minimum distance. And let's see. Oh yeah, see, that is the type of speed that I'm looking for when I do my dot density. And I know it says 22 minutes, but I might wrap this up because I have a meeting in 4 minutes. We'll call this white dot density. And let's do it again with African American. Point count from African American, edit, times 0.01. Run. We got a taste of what it takes like to draw a dot for every person, and it takes a long time. So we'll call this black dot density. And then now we have it down to a science, right? American Indian, but we have to remember to use it by 0.01. American Indian dot density. Keep going, never stop. Input layer, county census tracts. Field is Asian. And don't forget. Whoa, oh, there we go. I should have rounded it, whatever. So this is Asian. All right, so let's, we're not done yet. Meeting in 2 minutes. All right, gotta wrap up my random points, and then we can wrap up our stream. So county census tracts, points count, oh god, points count, Asian, Native Hawaiian, Pacific Islander, oh, can't forget, right, run. Pacific Islander dot density. All right, how many more we got? Field. Native Hawaiian, Pacific Islander, some other. I guess we'll just call this other, and we can't forget the most important part. Right, we'll call this other dot density. Uh-oh, 1 minute, meeting in 1 minute, meeting in 1 minute, meeting in 1 minute. Oh, yeah, this tracks. Field, whoa, no, it's because I want California census tracts, and I want field 2 or more. What? What's that? Gotta times it by 0.01. So it runs quickly. All right. So all of these, can I change all the styling on all of them at once? That would be amazing. And we want the size to be 0.2. No, I think it only does 1 at once. So we'll go through 0.2. Right, and the marker, no stroke. Marker, no stroke. And what's up with this one being enormous? 0.2, marker, whoa. Marker, no stroke. Marker, stroke. Marker. Isn't using QGIS fun? Marker, no stroke. Marker, no stroke. Marker, no stroke. Marker, no stroke. Great. I should make my dots a little bigger. If they're like this. So white is yellow. We'll let them be 0.6. Let's bump everybody up, and I need to take a screenshot and get out of here. All right, so that's actually kind of an interesting, fun color scheme. This is where people live. And let's turn this, make this a little bit more white. Right? I like this view's better. There we go. All right, I am already 2 minutes late to a meeting. I need to get out of here. Thank you to anybody who hung out, stopped by. Appreciate you. I'll probably hop on later today or later this week and keep on pushing on this fun stuff. But gotta